Laplace transform of periodic functions. We know what a periodic function is. Function, we show it as f of x plus, again, a capital T is equal to f of x for some value of t and all values of x. Okay, so here t is called the period of the function. Period. The Laplace transform of a periodic function is represented or is can be evaluated using this 1 by 1 minus e to the power of minus s capital T integral of 0 to infinity of e to the power of minus s small t f of t dt. Now let's derive this. Let's see how this comes about. Now, by definition of the Laplace transform, we know the Laplace transform of a function in general is integral from 0 to infinity of e to the power of minus st f of t dt. Yes. Now, remember this is 0 to infinity, right? But we also know in our case, since it's a periodic function, that it repeats, right? So which means we can split this into two integrals. Yes, the first integral will take care of the first period from 0 to capital T. So st f of t dt plus the second integral will take care of the rest from t to infinity e to the power of minus st f of t dt. Okay, now since this is repetitive, now this we have kept separate the first period, the rest is one function which repeats. So this, let's say that t is equal to u plus t, capital T. Now if we differentiate it, we get dt is equal to d, and our boundaries will become what? Our boundaries of this integral will become uh, t will become 0, because as far as this integral is concerned, that is the starting point, especially because it is repetitive in nature, and this infinity will remain infinity, right? So our two terms become 0 to t of e to the power of minus st f of t dt plus, now this integral becomes 0 to infinity of e to the power of minus s, t is u plus capital T, f of u plus capital T du. Okay, 0 to t of e to the power of minus st f of t dt plus, now let's split this e to the power of minus su times e to the power of minus s capital T f of, now f of u plus t is what? F of u, because it is periodic nature, f of t, f of u plus t is nothing but f of u du. Okay, so now what we can do is this remains as it is, this will carry it till the end, f of t dt plus, now here if you notice there is no u in this, so we can take it out, minus s capital T integral of 0 to infinity of e to the power of minus su f of u du, right? Okay, so now 0 to capital T e to the power of minus st f of t dt plus e to the power of minus st integral of 0 to infinity of, now instead of writing u, we can write t itself because it is still 0 to infinity. There is no distinction now. So let's write it as st f of t dt. And if you notice, this is nothing but Laplace transform of f of t, right? So which means 0 to t of e to the power of minus st f of t dt plus e to the power of s capital T minus. This is Laplace transform of f of t, right? And the left hand side is what? Left hand side is Laplace transform of f of t. So now here also we have the same. So these are like terms. Let's bring that to this side. So this becomes Laplace transform of f of t minus e to the power of s capital T. Laplace transform of f of t is equal to integral of 0 to t of e to the power of minus s t f of t dt. Remember, this is not a Laplace transform. Why? Because it is not 0 to infinity. Okay, so now let's, here this and this is common. So let's take it out. F of t times 1 minus e to the power of minus s capital T is equal to 0 to t of e to the power of minus st f of t dt. Now let's take this to this side. So this becomes 1 minus e to the power of minus st, or much more appropriately we can write it as is equal to 1 by 1 minus e to the power of minus s capital T times integral of 0 to capital T of e to the power of minus st f of t dt, which is what we had to derive. See here, f of t, the Laplace transform of f t equal to 1 minus e to the power of minus f st integral of 0 to infinity of e to the power of minus st f t dt. Okay, so now that we have that in place, let's solve one problem. In future sessions, we'll solve many functions, or rather find the Laplace transform of many functions. Let's start with one. So the first is f of t is equal to f of t plus 2 pi by omega. This is a periodic function with period is equal to 2 pi by omega. The function itself is sine omega t if t is between pi by omega and 0. 0 to pi by omega, it is sine omega t. If it is between pi by omega and 2 pi by omega, then it is 0. Okay, let's look at this. We know the Laplace transform of a periodic function is equal to 1 by 1 minus e to the power of minus s t, capital T, which is this 2 pi by omega, right? Times integral of 0 to capital T. This capital T is 2 pi by omega e to the power of minus st f of t dt. Now what we are going to do is we are going to split this integral. So 2 pi s by omega. Remember here this is a discontinuous function. So let's split this integral as well. So this would be integral from 0 to pi by omega e to the power of minus st sine omega t dt. Yes, plus integral of pi by omega to 2 pi by omega e to the power of minus st. Remember the function is 0, so 0 dt, which means that this cancels out, not required at all. Okay, So this becomes 1 by 1 minus e to the power of minus 2 pi s by omega times. Now what do we do with this? Integral of 0 to pi by omega e to the power of minus st sine omega t dt. What do we do with this? Now here you have to remember a particular integral EAT, the integral of EAT sine mt dt is equal to e to the power of AT by a square plus m square. Remember, a is this, m is this. So e to the power of AT as it is, a square plus m square times a sine mt minus m cos mt. Similarly, we require this. We don't require the second one, but I'm just mentioning it. In case of cos, what happens? Cos mt dt is equal to e to the power of at by a square plus m square a cos mt plus m sine mt. So out of this, we are going to use this to solve this integral. So the integral would be 1 by, next step would be 1 minus 2 pi s by omega times e to the power of, now here if you notice, uh, a is minus s, right? So minus st by s square plus omega square, right? So here m is omega square times a is minus s, so minus s sine omega t minus omega cos omega t, 0 to pi by omega. Okay, 1 minus e to the power of minus 2 pi s by omega. Let's apply this boundary values. So e to the power of minus s t is pi by omega by s square plus omega square. We could have taken it out. Okay, any minus s sine omega t. So omega times pi by omega. So pi omega cancels, pi is left. Sine pi is 0. So this itself becomes 0, which means we don't even have to write it. Okay, here what happens? Omega times pi by omega. That means uh, this would be cos pi. Cos pi is minus 1 minus omega, minus into minus plus omega, so omega. Okay, minus, now let's substitute 0. If we substitute 0 here, what happens? E to the power of 0, that is 1. So 1 by s square plus omega square times, now here what happens? Sine 0 is 0, cos 0 is 1. So minus omega. Okay. 1 by 1 minus e to the power of minus 2 pi s by omega. Here what happens? If you notice, omega is common to both. So let's take omega out. Let's take s square plus omega square also out. So we are left with e to the power of minus pi s by omega minus into minus plus 1. Now this and this looks, somehow we should be able to simplify it. So by omega by s square plus omega square times, this is e to the power of minus pi s by omega 1 plus, let's say, right? Now here it is 1 minus, but it is 2 pi. Here it is minus pi s by omega. Here it is 2 pi s by omega. So which means we can split this into 2. So 1 minus e to the power of minus pi s by omega times 1 plus e to the power of minus pi s by omega. Now let's very quickly multiply this and see, this is a minus b times a plus b. So which is a square minus b square. So a square is 1. Great. Minus square of this e to the power of minus pi s by omega. So square of this will be minus 2 pi s by omega. So perfect. That means this and this cancels out and we are left with omega by s square by omega square times 1 minus e to the power of minus pi s by omega. So that is the Laplace transform of this function. What function is that? Function is, you have to remember this. I'll tell you why. This is sine omega t when t is between pi by omega and 0, or 0 and 0 to pi by omega, and it is 0 when it is between pi by omega to 2 pi by omega. The reason why you should remember this is because it is a very special type of function called the half wave rectifier function, and by the name itself should tell you that it is something to do with electronics, and which means basically that in physics you will be using this. Okay, anyhow, I think that's enough for today. Bye for now.